Next, we're going to look at this box model. There's a description file that talks about some of the boundary conditions and about the venting airflow that was computed. A couple pictures of the model. Here's the outside of the box. If we look at some of the groups, you'll see there's a lot of different parts, but these last two show a view inside. So it's composed of a couple PC boards, has components on one board, has a big power device mounted to the back wall, has contacts between the edges of the PC board and the wall, which is a edge to a surface sort of contact, where we take that edge and that whole surface and connect them. We have components that are mounted to the board and this power device that's mounted to the wall. There's also a lid with contacts. If we look at a couple of the contacts using a contact visualizer, here we can see the contacts for the card guides, and if we come in, also turn on this one, you can see how they're hooked up. You notice that this element, it falls in between. If I zoom in here, you can see the edge falls in between one element, and so there's contacts going up and down. It will hook up past the power in both directions. If this board was down lower right along that seam, it would only hook exactly to the nodes there. If it's a little bit above, it would strongly connect to this node and then very weakly connect up to this node. So let's go ahead and run this model. And this model has radiation, and we've used Cinderad, and we're using the faster flux method. So the first thing that's going to happen, it's going to compute the view factors, and we're doing that in the background. We're not running it interactive in this model, and you can see the 3D model here rotating as it computed the view factors. That took about 12 seconds. Now it pre-processed the model and it just solved it. So it ran this whole problem in maybe 15 seconds. And this model has venting, which was computed in using one-way flow conductors, and we hand computed based on the temperatures what that updraft would be in pounds mass per second of the air. And if you would run this in a Flowtherm or IcePack CFD sort of package, although you would have more information about airflow, you may not have any better answer than some of these hand-computed correlations, convection correlations, but it would take hours to run and not seconds. Let's look at the results here. So we'll bring in our results, access results, apply. You can see we've brought in results and run this model many times in the past. And here's the PC boards, and you can see there's a lot of power and higher temperature, 65 degrees there. Let's turn on our element edges. And now let's look at a different view. Turn off our geometry here. So here you can see the hotter components running 95 degrees, but the board below it runs 60 some degrees. That's our card guide contacts. And here's our component contacts. Let's put the geometry back on. And let's make it wireframe. Get rid of our colors here. And you can see, turn on a solid, you can see the components, how they're connected to the board. And again, if the component is not exactly lined up, it will hook bar conductors going from like that node out to here, but they'll be much weaker than a node that's closer to it. The further the node is, the weaker the connection, but some of the energy does get out into that node, and that's why it's modeled this way. So these are automatically done. If we look at our loads, you can see under convection, contact convection, we have several different types of loads. The case to board contact between the components, and you can see surface 1, which would be that PC board below it, is hooked to the faces of these solids, the bottom faces. And all we do is hook the bottom faces of each of these little bricks to the surface that represents the PC board, and then that's automatically done at runtime, all the contacts. And we use our contact visualizer here in order to see these contacts, turn them on or off. So these little orange connectors are visualization only. They're added to the Cinda model, but they're really not in Patran. We can just bring in the contact visualizer feature, and it draws little plot-only bar elements to show you how the nodes are hooked up. And if we would decide to remesh the PC board, a finer mesh, and run it again, it would redo the contacts at runtime. So the contacts are determined at runtime, and they're independent of the mesh. You can apply them to geometry, and then they automatically will be created. And you can see we also have the PC board card guide contacts, and here it's from these are edges of the surface, for example the edge of these two surfaces, and then surface 7 and 10 are those two walls there. So we're looking at the 4 edges of these different surfaces, and the PC boards, it's an edge to a surface sort of contact. So again, those are very easy to put in, and then they're automatically computed at runtime, and we can post-process and also add those to our model if we want to see them. So this concludes the model of an electronic box.